Good evening, everyone. I'm Martino Lombardi, a PhD student of the first year in computer engineering and science. My tutor is Professor Rita Cucchiara, and the title of the presentation is Sensing Floors for Human Motion Capture and Action Recognition. We believe that surveillance systems can really benefit from the integration of multiple and heterogeneous sensors. At the same time, we know that research activity on natural and innovative interfaces aims at developing devices able to capture and understand the human behavior. So, our research activity starts from the idea that the pressure field generated by people and objects on the floor can be captured and analyzed in order to resolve this open-ended problem. And we hope that the outcome of our work also will also improve research sectors and industrial sectors such as e-health, security, building automation, social analysis, and so on. How do you sure know? From 1997, when J. Paradiso of MIT Institute of Boston proposed this famous magic carpet, several prototypes of sensing floors have been proposed in the past. But none of them fulfilled the following requirement, which we believe are important to generate a really bold solution. For example, the low cost of sensing elements and the high scalability of a proposed system are important requirements in order to obtain a good coverage of rooms, as well as wide areas. At the same time, a good sensing floor must be transparent to the user, and it must have a temporal and spatial resolution high enough to allow the people detection tracking, even in presence of multiple targets. So today, I'm glad to present to you an innovative sensing floor called the Floor Image System, developed by the Image Lab laboratory of our university. The system is composed of four principal elements: the sensors, a capturing board, the communication network, and the process unit. We started from a common paving technology called floating floor, not needing to be glued or fixed on a sublayer. It consists of a polymeric layer made of cork or felt, holding up a laminate floor. How you can see from the picture, the traditional polymeric layer has been replaced with a sensing element made using a sandwich structure. When a pressure is applied on the top of tiles, the surface of the conductive rubber layer is compressed onto the electrodes surfaces. And as a result, the contacting area between the electrodes and the rubbers is increased, and the resistance between them is proportionally reduced. The resistance at each cross is acquired thanks to a capturing board depicted in which the scheme is depicted in this slide. Every sensor, we constitute a sensor grid that we consider we call base node that are composed by 16 rows and 8 columns in order to generate 128 sensor units with a spatial resolution of 13 centimeters. So you can take several base nodes and place it side by side in order to cover wide areas. In order to obtain people detection and the further classification of their behavior, we're using a common video processing and analysis techniques. Because you can see the output of the floor image system as a pressure image, generated by people and objects on the floor. So, for example, we extracted 3D spatiotemporal patches, selecting a rectangular region on the floor, for example, a tile, and we collected the data values from the sensors below it. For a brief time, for a short time, about 2 seconds, which corresponding with 20 frames at the frame rate we used for experiment, with different people on the tiles and in a different position and with different objects posed on the top of tiles. So we computed a feature vector of 15 elements, 15 elements on each patch. In this slide, you can see the mathematical definition of the element of the feature, the 15 elements of the feature vector, and so obtained. And sorry for the photo. It's not so good, but the so obtained feature vector as provided as input to a set of supervised classifiers trained to recognize the presence of a person on the top of a tile or of a simple object on the top of the tile. When a person is identified, the same feature vector is used to learn, is used to classifying these simple 5 for action. And at the end, we obtained a set of random trees classifiers trained for both the tasks. And we are selecting this kind of classifiers because you can see from the data reported in the slide, this kind of classifiers had the best results in accuracy during our experiment. In conclusion, we described an innovative sensing floor that is possible to use in a plethora of applications, such as surveillance or entertainment, and so on. The characteristics of the system completely fulfill the requirements to generate a reliable and industrial solution, and at the same time, preliminary tests on laboratory prototype confirmed the possibility to detect the presence of people on the floor and to classifying some simple behavior. In future, we want to increase the number of behavior, the identifiable behavior, using other pattern recognition techniques, and we want to develop a good tracker, even in the presence of multiple targets. Thank you.
So you are saying that you should be able to track any single person walking on the floor?
Yes, yes.
Okay, thank you.